Hello and welcome to ninth lecture in our 19th chapter of our comprehensive course of data science, AI and machine learning. Now, the name of this chapter is Basic Statistics, and though it is named Basic Statistics, it is pretty long and extensive and exhaustive chapter. And thereafter there are still two more chapters. One is Advanced Statistics, and then there is one more chapter on statistics. Okay, so last time we were doing about permutations and combinations. That was lecture 8. Now this is lecture 9. We want to talk about probability. Actually, this whole discussion about permutation and combination and the discussion about probability started because we did this some discussion about this statistical distribution, and statistical distribution includes data distribution and probability distribution. So we did a little bit discussion that what is the difference between the two things and how the two are connected with each other. But next we want to understand various probability distributions in much more details. Like for example these, right? These are various probability distributions, or these what are shown in the diagram. So but before we discuss probability distribution, you have to have some idea about what is the concept of probability. So for that we first did one topic called permutations and combinations, and now we are starting to introduce what is exactly probability. So probability is defined as number of successful events divided by number of possible events, or number of favorable outcomes divided by number of all possible outcomes. What is the meaning? Very simple example. If I do a coin toss, then what are the number of possible outcomes? Then either it can show head at the top, or it can show the tail, right? So that means these in the denominator, total possible outcomes are 2. I'm not considering the rare possibility where the coin stands vertical, but apart from that, that is the total possible outcomes are 2, right? Now, however, suppose someone asks you that how much is the chance or the probability that tail will come when I have tossed and the coin is in air, then what is the chance for tail? So at that time, favorable outcome, that is the outcome which I want, that is 1 only, tail, and divided by how many are possible when the coin is still in air, then they are 2. So that is 1 by 2, or you can say 50% chance of getting tail, and 50% chance similarly for getting head also, if it is a fair coin. That is no cheating is done by making one side heavier or something like that. Okay, so if it is a fair coin, then both head and tail, they have equal outcome. Another example is what is the odd of getting say any number out of 1, 2, 3, 4, 5 and 6 while rolling a die. So that also we know that that is a cube and it has 6 surfaces. Okay, on one surface only 1 dot is given, on another surface 2 dots are given, on another surface 3 dots are given. So the total on the 6 surface is 1, 2, 3, 4, 5 and 6. These numbers are there, right? Now you want to decide that when a die is rolled and it is still rolling, then what are the chances of getting say 3? So at that time, again, favorable outcome is only 1. I want 3 only. Okay, but possible outcomes 6. Again, it is assumed that it is a fair die, and therefore there is no cheating done that one part is manipulated somewhere, that only that number will appear more number of times. So in that case, it is clear that 1 is favorable outcome, that 3 will come, that is only 1 favorable outcome, and total either 1 can come, or 2 can come, or 3 can come, or 4 can come, or 5 can come, or 6 can come. So what are the probabilities? What is the probability of getting 3? Then that is 1 by 6. Similarly, what is the probability of getting 4? That is also 1 by 6. What is the probability of getting maybe 2, 3, 1 or any other number out of 1 to 6? Then all are 1 by 6. So about probability, you see one important thing, that when you count all the possible events, then their total probability would become 1 only. Okay, so that is means that if someone asks what is the probability of getting head, 1 by 2, and what is the probability of getting tail, 1 by 2 for a fair coin, so that 1 by 2 plus 1 by 2 total probability is 1. Here, what is the probability of 1? 1 by 6, 2, 1 by 6, 3, 1 by 6, 4, 1 by 6, 5, 1 by 6 and 6, also 1 by 6. So 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6, 6 times. So that is 6 by 6, and that means that will be also 1. So if I consider all possible events, then the total of all probabilities, that should always be 1 or 100%. Okay, if I write in percentage. Now here in the rolling of die, I can say that what are the chances of getting either 3 or 4. Now there at that time, in the denominator, total number of possible outcomes are still 6, but in the numerator, favorable outcomes are now 2, because I am saying I will be happy if either 3 is there or 4 is there, right? So in that case, 2 divided by 6, so that is 1 by 3 will be the probability of getting the number on the die after rolling, getting 3 or 4, right? Okay, fine. So now drawing a card. So if there are 52 cards, when everybody has seen and played with cards at some time, and there are 4 colors, right? 4 colors are also there, and 4 types of cards are also there: heart, diamond, club and spades. Okay, so everybody knows these 4. Now Suppose it is asked that card is randomly arranged, that is it is properly arranged, so it is not, there is no cheating. It is before, that is why before distributing cards we always do the reshuffling again and again and again, and then it is perfectly shuffled cat of 52 cards. Now you are drawing one card out of it randomly, then what are the chances that there would be a king? Now at that time think how many kings are possible. Then in entire 52 card set there are 4 kings possible, these 4. Okay, so then among them, so that are favorable outcomes. I would be happy if I can get any one of these 4 kings. Okay, so total favorable outcomes are 4 and total possible outcomes are 52. So 4 by 52, or that is 1 by 13, that is the probability of getting a king. But however, if someone asks what is the probability of getting king of heart only, now I am insisting that these 3 are not my favorable outcome. My favorable outcome is only 1. I want to get absolutely the king of hearts only. Okay, so in that case, favorable outcome is 1 divided by total possible outcome is 52. So then the probability will become 1 by 52. Okay, right. Now, another example is this. Suppose someone says, now this is how probabilities are written. Probability of heads, so P heads. Probability of getting 4 while rolling a die, so P4. Probability of getting a king while drawing any random card from a set of 52 cards, so that is P king. Similarly, if someone says that the probability of rain tomorrow is forecasted as 30%, how you will write it in as this? Then you will write that P rain equals 0.30%. Now suppose there are only 3 weather possible: rain, cloudy, and sunny. And suppose I say that rain has 0.3% or 30%, cloudy has 40%, or say 50%. Cloudy, that much is forecasted, that 50% is the chance of having weather cloudy. So then what will be the chance for getting weather sunny? So as I say, total probability is always 100%, among which rain probability is 30%, cloudy probability is 50%, so 50 plus 30, that is 80%. So what is the probability left? That is the probability of having sunny weather tomorrow. Okay, so that is 100 minus 80, or that means that will be 20%, right? Okay. Similarly, suppose you have made a machine learning model for spam detection. Okay, that is called a spam ham classifier. Now that is an interesting application of this probability, because suppose you have a big organization and you are running your workplace blog, and it is a very famous blog. So you know that when you write a blog, there are several feedbacks which are given to you, and some are actually useful feedbacks, but some are spam, pure spam. So now if you want to filter them, spam ham, or suppose you have an email server, you are running an email server. Now you are a big company and you are taking customers feedback through emails. So there also, on one side, you don't want to miss a really genuine business email, right? Because it might have some big order proposal, and if you classify that as a spam and it lands in your junk box and you don't check it, then you will lose that business. But on the other hand, so on one side you don't want to make a false positive detection. False positive is this, that it was not a spam, but your email spam ham classifier has detected it as a spam. But on the other side, you also want to avoid, you also want to maximize true positives. True positives means what? That if the email is actually a spam, then in that case your classifier, whatever algorithm you are using to detect spam, that should detect that it is a spam. So out of 1000 spam emails, if it detects around 990 correctly as a spam, then you will say that that means it is having a 99% accuracy for detecting true positive, right? So that is something which is required. So suppose there is one such classifier, and there are actually 100 total spam emails coming to the server, and it detects 80 as correctly as a spam. That means it misses actually 20 which were also spam, but it misses them, and it allows them to go into the inbox. Okay, so then what is the probability of this email, this classifier, that it will predict a spam correctly? Then it will be favorable events 80 divided by all possible events 100, right? So that is the definition of probability. So that is 80 divided by 100. Or you will say that my classifier predicts the emails as spam with 80% accuracy. That is, if 100 spam email would come, then it would give 80 of them correctly detect and put them in the spam folder, but 20 spam emails will escape and they will go into the inbox folder. So unnecessarily you will have to open it, and then you will have to check it, right? Now this posterior probability and this Bayes theorem. Okay, so this is actually more important than simple probability, because in simple probability there is nothing difficult. Favorable outcomes divided by all total possible outcomes, that you have to think. Now posterior probability takes the whole concept one step ahead. In this, you have to remember these 3 concepts: prior probability, likelihood, and posterior probability. So prior probability is called initial belief before observing the data. And when we take examples, then only this becomes clear. So it is initial belief before observing the data. For example, you have patient's data and you decide the initial probability that all these patients have the disease. Okay, so that is initial belief that this is the data of all patients who have the disease, or all these patients do not have the disease. Any one initial belief you can take. Okay, then likelihood is the probability of observing the data given some hypothesis. Now this is a totally different thing, that you make a hypothesis that out of my sample of 100 patients, at least 5 should be having tuberculosis. So that is your hypothesis. Hypothesis means it is not some hard and fast firm result. You have to check your hypothesis. Okay, so out of 100, you made a hypothesis that 5 are having tuberculosis. Now, if when you actually check all 100 patients for TB, you make some tests, etc., and you get that only 4 have tuberculosis, then what is the probability of observing the data as per your hypothesis? So then, out of 100, you got 4 actually having tuberculosis. So that means your probability of observing the data as per hypothesis is 4 by 100. That is called likelihood. Okay, fine. And we will take more and more detail. In fact, data science, as the course continues, these words will be again and again be used, and you will get so many examples that it will become more and more clear. Then posterior probability is the updated probability after observing the data. So you made some initial belief that if I take a sample of 100 patients, then at least 5, or say exactly 5 for making things simple, exactly 5 will be having tuberculosis. So that initial probability is 5 by 100. That is called prior probability. Okay, but when you actually did the test for tuberculosis on the 100 patients, then you realize that actually 4 are having the tuberculosis. So that means when a new sample of another 100 patients will come, now you are armed with the knowledge. So you can, for the new sample, if someone asks you a question, what is the likelihood that 4 will have tuberculosis, or what is the likelihood of having tuberculosis from a sample of this 100? So you will say that it will have 4 by 100. Okay, and what is the posterior probability? So that is also here in this case, it is 4 by 100. Correct. So because after observing the data, you have updated the probability for that first sample, but likelihood is always for future data. That future data will be behaving as per my hypothesis. Okay, so it is likelihood means I would observe the data as per my certain hypothesis. Okay, now what is Bayes theorem? The Bayes theorem is given by this kind of equation, where how to read this equation. This is probability of A, and this vertical line is not the division symbol, but it is probability of A given B. Sometimes we also read probability of A after B. After means what? Probability of A when B is already given to you, that B has already occurred. Okay, so better would be the probability of A given B is equal to, this theorem says that if you can't find this, then instead of that find this probability of B given A multiplied by probability of A. Now that is simple probability, that is this probability, and that is always easiest to find. Favorable outcomes divided by total possible outcomes. Okay, so if you can't find probability of A given B, then find probability of B given A and multiply it by probability of A divided by probability of B. Is it clear? Okay, so that will give me probability of A given B, right? Okay, fine. Now here we take some examples to make this Bayes theorem more clear. So first is this example. Say a medical diagnosis example we are taking. So, or let us continue. There are 3 examples, I think, and it will take 4 examples, 5. Okay, so I will continue this in the next lecture, because all these examples must be done in one only. Then only it becomes perfectly clear. So we start with, just at present remember the equation and how to speak the equation of Bayes theorem. And this is one of the most fundamental theorem for data scientists, Bayesian probability. This probability is also called Bayesian probability, or another word for it is posterior probability. That is probability of some event when some B event has already occurred, or probability of event A occurring when given that event B has already occurred. Okay, so we'll see that because it requires a lot of explanation. So next lecture. Thank you.